Good morning. You've got 7 screencasts total to watch, so please watch all of them. Each screencast is a separate question. Perhaps watch the first 1 or 2 screencasts and just get a feel for the problems by doing them with me. Once you feel confident, it'd probably be a good idea for you to try to complete the questions independently before you actually watch the screencasts. So we'll start with question 1. And I've just highlighted here some of the words and the equations that I think are poignant. So the decay of a radioactive substance is modeled by Q of T equals Q0 times 1.7 to the power of minus KT. Q is the amount of the substance present at a particular time, T in years. Now it's important that we remember that time is in years. Q0 and K are positive constants. So first part of the question, we're asked to show that the constant Q0 represents the initial amount of the substance. Now if we recall from previous application tasks that we can calculate initial conditions or quantities or amounts by allowing the time to equal 0, which if you think about it makes sense. Initially, time is 0. So initial quantities or amounts are usually symbolized by a pronumeral that has a subscript 0. So for this question, that symbol here, that Q of 0, is a representation of an initial amount. The notation Q of T, now we've seen things like this before because we've done F of X. So this is, all it's saying is that it is the amount with respect to time. We should also reflect upon the fact that in the equation that they've given us, we have a negative in the index. And so that negative implies that we're dealing with a decay model. And we should remember from previous discussions of exponential graphs that it looks like this one that I've got here on the right. So if we're going to find an initial amount, then we need to let T equal 0. So if we let T equal 0, we've now got Q of 0 is equal to Q0 times 1.7 minus K times 0. K times 0 is just 0. So in fact, that index is just to the power of 0. And we should remember that any number to the power of 0 is just 1. So this is Q0 times 1, which is just Q0. So what we've shown there is that Q0 is equal, so Q of 0 is equal to Q0. It's a little bit confusing. So at when time is 0, the initial amount is Q0. Second part of the question, we're asked if the half-life of the radioactive substance is 300 years, calculate K to one significant figure. Now you may not be familiar with the terms half-life or significant figure, so I might define them for you. So the half-life of a radioactive substance is the time it takes for the amount of the substance to halve. So for instance, if I had 40 kilograms of a radioactive substance, the half-life would be the time it takes for that radioactive substance to decay to only 20 kilos. So what we're going to do, we're going to write down the information that they've given us. Good habit, if you're using equations and making many substitutions, is just to write a little list of the things we know. So we are given that the half-life equals 300 years. We know the initial amount. and we're referring to the initial amount as Q0. We also know now from the previous question that K equals, oh no, we don't know that yet, that's what we're working out. So we know the initial amount is Q0, we know the half-life is 300. After one half-life, the amount of substance will be half of Q0, half of the initial amount. So we're going to substitute these values into our formula. There's our formula. So we're letting Q of T equal half of the initial amount. We've got a Q of 0 on both sides, so we're going to just divide through by a Q of 0 to get rid of it. So that we're left with 1/2 equals 1.7 to the power of minus 300K. And at this point, we can just put that straight in our calculator. We need to write down exactly what we're doing, particularly if it was an exam question. So what we're going to do on our calculator, we're going to go to solve. We're going to type in our equation. And we're going to ask the calculator to solve that for K. So we go menu, 3, 1, type in what we need. So I'm going to write 0.5 instead of a half, equals 1.7 to the power of minus 300 times K. Don't forget the comma K. Now calculator tells us that is 0.004354. So it tells us that we've got K equals Now if we have a look at the question, it asks that we calculate the half-life, also calculate K to one significant figure. Oops. So what that means is we can only include the first figure that isn't 0. So that would be 2 significant figures, but we want 1 significant figure, so it would only be K equals 0.004. Now we could actually find K, or an exact value for K without using the CAS. It's a little bit longer, not as efficient, and we don't actually get an answer that really means anything. So if we did that, we'd start with our half equals 1.7 to the minus 300K. It's an indicial equation, so we'd have to find the logarithm of both sides. Log to the base 10. The minus 300K that's in the index there, we could take out the front of the logarithm on the right-hand side using our log laws. And instead of a half here, I'm going to write the half as 2 to the negative 1. Now, if we want to get K by itself, we've got a minus 300 multiplying it, and we've got a log to the log base 10 of 1.7 multiplying our k. So in order to get k by itself, we need to divide through both sides by minus 300 log 10 to the 1.7. So if I take the negative, this negative here out the front as well, then the negatives should cancel. So we'll get log 10 to the 2 divided by 300 log 10 to the 1.7. Now that gives us an exact answer for k. If we wanted an approximate answer for k, we'd still need to use our cas. So really, doing it this way was not beneficial at all. Would still need cas. The method is really it's just too long. So for this type of question, you would always use your cas in an exam. For part C, if initially there was 250 kilograms of a radioactive substance, how many kilograms would decay in 10 years? So we're going to also use that, that K value that we just calculated. So again, we're going to write a little list of the things we know. So we are given that the initial amount of radioactive substance is 250 kilograms. We're told that 10 years has elapsed. And we also know that our K is 0.004. So if we substitute those into our initial formula, got Q of 10, Q0 is 250, times 1.7 minus 0.04 T. Oops, putting T in there. We're told that T is equal to 10. So putting this value into our cas again. So we're just going to put that into our cas. So I don't need an action this time, we're just going to put it straight in. So we're going to write 250 times 1.7 to the power of minus 0.004 times 10. I've done that in my head. And that is equal to 244.75. Now that is not the answer, because if we read the question, we didn't have 244.75. What they asked us was, if initially there were 250 kilograms of the radioactive substance, how many kilograms would decay? Not how much is left, but how many would decay in 10 years. So we know that we've got 244.75 kilograms left. So the answer, in fact, is our 250 kilograms that we started with, minus the 244.75 that we have left. And what we get is about 5.3 kilograms has decayed. Now, you should try as best you can to answer worded problems in sort of sentences or statements like this. So 5.3 kilograms has decayed. So that's the end of question 1.